Applications of integration, lesson 5. Here we're going to look at Simpson's rule. So our content in this lesson is apply the numerical method Simpson's rule to approximate the area under a curve and use technology to evaluate results. Simpson's rule. Simpson's rule is another way to approximate the area under a curve. The region between A and B is divided into n intervals where n is an even number. So numbering is this x subscript 0 up to x subscript n. So if we're up to say 10 intervals, we'll get up to x10. To look at this in terms of a diagram, we've got the curve y equals fx. If we want to break this up into a certain amount of windows or subsections, we have our starting point, which is x subscript 0. That is located here. Our final one, which is b, is up to xn, and that could be, say, the 8th window along or the 12th section along. What we're going to do is use a different approach to the trapezoidal rule to actually approximate the area underneath this curve. Unlike the trapezoidal rule, this approach sees a parabola fitted across 3 points within 2 intervals. This approach is considerably more accurate than the trapezoidal rule. Simpson's rule for approximating the definite integral is given by the following. So the area under a curve given by the definite integral of fx between a and b is a very long formula, which is part of your formula page, which is w over 3, or 1/3 w. We now have our fx in terms of our left outermost boundary up towards our right outermost boundary, and we have 4 and 2 here. Now note these ones here are our odds, and here when we're doubling them, they're our evens. And note where w is your upper limit, take your lower limit divided by the number of intervals. So example 13, use Simpson's rule with 6 strips to determine the approximate value of the definite integral. Now this one's a bit trickier. So we've got negative cos root x plus 2 dx between 0 and 3 pi. So what we need to do first is determine the number and widths of the intervals. And it said 6 strips. So now we use that formula, w equals b take a n. So here we're subbing in our terminals, our lower and upper boundaries. So 3 pi take 0 and 6. That means the widths of our sections are going to be pi and 2, our strips. Step 2 is determine either a table of values of all our coordinates that make up the 6 sections. So from a graphical point of view, I have our graph of negative cos root x plus 2. When I'm pi and 2 across on this graph, if I sub that into the equation here, the output value, the y value, to 2 decimal places is 1.68. Likewise, if I sub in 3 pi into this equation here, my resulting y value is 3. So fx1 is this coordinate point here, where x1 is pi and 2. Now, this has been done for us in terms of a graph that has the necessary information on it, which is here, 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 and here. Using those coordinate points, we can actually apply Simpson's rule. That might come on a table using technology, or maybe in the question, the actual graph has that information for you. So the GeoGebra estimate or approximate is 22.41 as the area underneath this curve. We'll now use Simpson's rule. So state the formula for Simpson's rule, which is on your formula sheet. In this case, remember, this fx0 is 1. The fx1 would be the 1.68. For instance, fxn would be our 6th one, which is here, the y value of 3. Next step is to write the formula to approximate the definite integral. Here was the integral, the definite integral that we were trying to evaluate. Applying Simpson's rule, I'm now going to sub in my values that I've determined on the previous slide. W, if you recall, was pi and 2. My left outermost boundary and my right outermost boundary was 1 and 3 respectively. x1, x3, so on are my odds. So here I've subbed in those points. x2, x4 are my evens. studying those points. If we multiply the sum of the odds by 4 and the evens by 2, we're going to evaluate this using a calculator. The actual answer is approximately 22.36 square units. That's pretty close to the GeoGebra's approximate, or pretty much correct answer to 2 decimal places, which is 22.41. So Simpson's rule using 6 strips was pretty close in terms of, or reasonable answer in approximating the area under the curve. Test your understanding. Calculate the approximate for the following definite integral using 8 strips and applying the approach of Simpson's rule. The answer, which is using technology, is 2.414. So you can check the reasonableness of your result using an approximate method and compare the two answers.